I think we got past this last time. This is just the vocabulary associated with solving a system of linear equations. If I remember correctly, actually, I think we actually got up to the substitution method. Okay. So if I remember correctly, this is what we got up to. I mean, if I'm wrong, somebody say something or okay. But basically, the way we can solve these systems of linear equations, there's actually different ways of doing that. One of them we'll see is actually pretty simple. It's using Desmos. The other way, another way that is using what's called substitution. There's also elimination, which you might have seen before. I think most people have seen it before, but we will go through it as well. Okay. So for the substitution method here, the example I did last time actually illustrated the process of substitution. Essentially, what you do is this. You're going to take one of the equations. Remember, we have two equations here in two unknowns, okay? So you're going to take one of those equations and solve to get one variable in terms of the other. That's what you do in the substitution method. Then, if you remember this example here, we actually did it last time. That's actually what we did, right? Here, we got y in terms of x. You could get x in terms of y if you wanted to. You could do that. So, either way. But here from the first equation, we got y in terms of x. What you next do is you substitute the expression you found in step one. You're going to plug that into the other equation. Mostly because what's going to happen is you're going to kill off one of the variables, okay? That's actually what we did here, right? Once we got y in terms of x, we substituted that into the other equation. Doing so, what happened? Well, we killed off one of the variables, right? Essentially, we get an equation in only x that we were able to deal with, okay? You solve that equation, that's what we did. We substitute, right? We solved that, we got x equals 3. We substituted that back into, what was it called? We substitute back into the value from the previous step into the expression we got in the first step above. In other words, what they're saying here, what I'm saying here is, once you know what x is, you can easily get y because you have y in terms of x. So essentially what you do is you plug in what you get for x, then you're going to get y. And then, of course, you can check your answer. So basically what I'm saying in step 4 is you're going to substitute whatever you get from solving the equation. You get one of the variables. You're going to plug it into the expression you found in 2, the equation you found in 2, excuse me. Not 2, excuse me, 1, sorry. In 1, that's what we did. You're going to substitute it back into 1, and that will give you the other variable. You know, you have to get the values of the variables. That's really what you're after. Okay. But we did one example. Here's another one. So here we have 2x minus y equals 5, okay? We have 4x minus 2y equals 15. And so what we want to do is we want to solve this. Now, just like we did with the other example, from the first one here, from the first equation, we can get y in terms of x. I'm actually doing that because notice the coefficient of y is actually a 1. I mean, we're subtracting. But to me, that's why I would think to put y in terms of x from the first equation. So, you know, just by basic algebra, and really just like the previous example, right? Just like this example here, the 2x minus y equals 5, you get y is negative 5 plus 2x. Same thing over here. We get y equals 2x minus 5. And then by substitution, you're going to plug that back into the second equation, okay? You're going to plug that back into the second equation, okay? And we do that, right? We get an equation in terms in only one variable, x. We get 4x minus 2 times 2x minus 5 equals 15, right? That's what we get here, as you can see. Now, when you actually carry out this distribution, you know, orders of operations, you're going to have 4x minus 4x plus 10 equals 15, right? So, of course, the 4x's cancel, but watch what happens. You get something like 10 equals 15. We have an equation. I mean, you could subtract 10 from both sides and get 0 equals 5. But we have something here that's just false no matter what, right? This equation is false no matter what. What does that tell us? There are no solutions to the system. There are no solutions to this system. That's what this is telling us. No solutions, okay? Okay. For this example, it's a little bit different. I mean, essentially the first equation is the same. So we again get the same, we get y equals 2x minus 5. And again, we substitute. We have 4x minus 2 times 2x minus 5 equals 10, right? This is what we have here. But now what's going to happen? Well, we distribute, we get minus 4x plus 10, as you can see. So the equation becomes 4x minus 4x plus 10 equals 10. Well, that's interesting. What happens? Well, the 4x's cancel. We get 10 equals 10. It's kind of like the opposite of this case, right? This is true no matter what. This is true no matter what. So what does that tell us? There are infinitely many solutions. There are infinitely many solutions here. Okay? Which is nice. Okay. Are there any questions on this? All right. So here's one I was going to have everyone try, actually. Okay. So what I'm going to do is I'm going to stop the recording. Okay. Let me pause it. Stop.